A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headache.
If you're building anything with AI, check them out. Modal.com. If you have ever tried to run a large language model on your own laptop, you have probably encountered a confusing alphabet soup of tools. You see names like Ollama, llama.cpp, vLLM, and llamafile being thrown around in every developer forum. It feels like this fragmented ecosystem where everyone has a favorite engine, but they are definitely not all created equal. Today's prompt from Daniel is all about these open source inference engines. He wants to know what they actually are, how they differ from the massive proprietary stacks used by the giants like Google and OpenAI, and why this fragmentation even exists in the first place.
This is such a foundational topic for where AI is heading in 2026. Herman Poppleberry here, and I have been diving deep into the internals of these runtimes lately. The reality is that we are witnessing a massive divergence in how AI is served. On one side, you have the big tech vertical stacks, which are these incredibly opaque, hyper-optimized systems designed for massive scale and custom silicon like Google's TPUs. On the other side, you have this horizontal open source world where the goal isn't just raw scale, but portability and accessibility on commodity hardware. By the way, fun fact for everyone listening to today's episode of My Weird Prompts is actually being powered by Google Gemini 3 Flash. It is the model behind the curtain for this specific discussion.
I love the irony of using a proprietary model to discuss the rebellion of open source engines. So, Daniel's prompt essentially asks why we need these tools, if the big players already have solved inference. He points out that Ollama, for instance, still has some hurdles with multimodal input like audio, which the big models handle natively. Let's start with the basics for a second. When we talk about an inference engine, what are we actually talking about? Is it just a glorified file reader for a model?
It is much more than that. Think of the model weights, the actual Llama 3 or Mistral files as a giant static library of knowledge. The inference engine is the librarian, the researcher, and the fast-talking presenter all rolled into one. It has to load those weights into memory, manage the math, specifically the matrix multiplications, and handle the KV cache, which is how the model remembers what it just said 2 seconds ago so it can generate the next word. The proprietary stacks at Anthropic or OpenAI are built to run on thousands of H100 GPUs clustered together. They don't care about your MacBook Air. These open source engines, however, are the reason you can actually run a model that rivals GPT-4 on a $3,000 Mac Studio with zero recurring costs.
That is the commodity hardware rebellion Daniel mentioned. But if I'm a developer, why am I choosing llama.cpp over vLLM? Or why am I using Ollama if it's just a wrapper? It seems like a lot of overlapping tools for the same task.
The differences are actually quite stark once you look under the hood. Let's start with the grandfather of them all, llama.cpp. This was started by Georgy Gerganov, and the secret sauce here is that it is a pure C and C++ implementation with zero dependencies. It pioneered something called quantization, specifically the GGUF format. Most people don't realize that raw AI models are massive. They use 16-bit floats for every parameter. Llama.cpp lets you crush those down to 4-bit or even 2-bit integers. That is the difference between needing 80 gigabytes of VRAM to run a model and needing only 8 gigabytes. It makes the big models fit into small pipes.
And that is why it works on Apple Silicon, or even a Raspberry Pi, right? Because it's not married to NVIDIA's CUDA platform.
Well, I shouldn't say exactly, but you've hit the nail on the head. It is the king of portability. If you are on a Mac with an M3 chip or an Intel NUC, llama.cpp is what makes it possible. It treats your CPU and GPU as a hybrid team. But the downside is that it's a bit of a low-level tool. You have to compile it, manage your own paths, and understand command line flags. That is where Ollama comes in.
Right. Ollama is the one everyone talks about because it feels like a consumer product. You just type Ollama run llama 3, and it works. But Daniel mentioned the multimodal gap. He noted that as of April 2026, Ollama's support for things like audio input is still catching up compared to the seamless multimodal experience you get with GPT-4o or Gemini.
That is a very astute observation from Daniel. The reason for that gap is that the proprietary models are often natively multimodal. They were trained to see, hear, and speak in one single architecture. The open source world often uses Frankenstein architectures. You might have a vision encoder from one project and a language model from another, and the engine has to stitch them together. Ollama is essentially a high-level wrapper. It uses llama.cpp as its engine, but adds a UX layer on top. It treats AI models like Docker containers. It has a model file that handles all the configuration for you. As for the audio bit, they are moving fast. Support for models like Qwen2 Audio has been hitting the dev branches, allowing users to feed in .wav or .mp3 files, but it's still more friction than the big tech experience.
So if llama.cpp is the engine and Ollama is the shiny car body, what is vLLM? Because I see that name coming up whenever people talk about production. Is that just for people with way too much money and too many GPUs?
Not necessarily, but it is built for a completely different goal. If llama.cpp is about how do I run this on my laptop, vLLM is about how do I serve 10,000 people at once. The breakthrough there was a mechanism called pay-get-attention, which came out of UC Berkeley. In a normal engine, the memory used to store the conversation history. The KV cache is very fragmented. It's like having a library where the books are scattered randomly on the floor. Paged attention treats that memory like pages in an operating system, fitting them together perfectly.
Does that actually make it faster for a single user? Or is it just about handling the crowd?
For a single user, you might not notice a huge difference, but in a multi-user environment, vLLM can handle 20 to 30 times more concurrent users than llama.cpp on the same hardware. If you're a startup building your own API to compete with OpenAI, you aren't using Ollama. You're using vLLM because at peak load, it can deliver 35 times the generative power by being incredibly efficient with how it batches requests. It is the production powerhouse.
Okay, so we've got the foundation in llama.cpp, the user-friendly wrapper in Ollama, and the server-grade beast in vLLM. Then there's llamafile. I've heard this described as AI on a thumb drive. That sounds like a bit of a gimmick. Is it actually useful?
It's actually brilliant engineering. It comes from the Mozilla team, specifically Justine Tunney. It uses something called Cosmopolitan libc. Essentially, it turns the entire AI model and the engine into one single executable file that runs on 6 different operating systems without installation. You can take that file, put it on a Windows machine, a Mac, or a Linux box, and it just runs. And here is the kicker. It isn't just a compatibility play. Recent benchmarks show that llamafile's prompt evaluation, that's the speed at which it reads your input before it starts typing, can be up to 500% faster than llama.cpp on certain CPUs. They've written highly optimized matrix multiplication kernels that squeeze every drop of performance out of standard CPU chips.
That's wild. It's like the ultimate prepper tool for the AI age. If the internet goes down, as long as you have your llamafile on a USB stick, you still have a world-class assistant. But let's look at the bigger picture Daniel is pointing toward. Why don't the big guys use this? If llamafile is 500% faster on some CPUs, why is Google building custom TPUs? Why is Anthropic writing their own custom CUDA kernels?
It comes down to the scale of 1%. When you are Google or Microsoft, you are spending billions on electricity and hardware. If you can write a custom static graph compiler that is only 1% more efficient than vLLM, that 1% saves you tens of millions of dollars a year. These open source engines are horizontal. They have to support 1,000 different models and 100 different hardware configurations. That flexibility has a tax. Google can build an inflexible system that only runs Gemini, but it runs Gemini with absolute, terrifying efficiency on hardware they designed from the silicon up.
So we're seeing a world where if you want the best, you go to the proprietary clouds, but if you want the private or the free, you use these engines. But is that gap closing? Daniel mentioned that these runtimes are what make AI accessible on commodity hardware. Are we reaching a point where a commodity setup, say, a beefy gaming PC can actually outperform a throttled API call to a big provider?
In terms of latency, we are already there. If you run a small model like Llama 3.8b on a modern NVID IA card using vLLM or even Ollama, the words appear faster than you can read them. It feels instantaneous. When you use a web interface for a big model, you're dealing with network lag, load balancing, and safety, filters that add processing time. For a developer building a coding assistant or a local search tool, the local first approach is actually the superior user experience.
Let's talk about that local first movement, because it's not just about the engines themselves, it's about what people are building on top of them. I'm thinking of things like anything LLM or OpenWeb UI. They use these engines as a backend. It feels like we're moving away from AI as a destination, like a website, and toward AI as a utility that just lives on your machine.
That is the real shift. These engines are the plumbing. Because of llama.cpp and Ollama, we are seeing the rise of RAG retrieval augmented generation that is entirely private. You can point a local tool at your entire folder of tax returns, legal documents, or private journals, and the engine processes all of it locally. The big tech providers have a hard time competing with that on a trust level. No matter how many privacy policies they write, some enterprises and individuals will never upload their most sensitive data to a cloud. These engines solve the primary privacy concern of the AI era.
It's also a hedge against API volatility. We've seen providers change their pricing, change their vibes, or even just go down. If your business depends on an API and that provider decides to deprecate the model you spent 6 months fine-tuning, you're in trouble. With these open source engines, you own the weights and you own the runtime. It's a form of digital sovereignty.
And it encourages a different kind of innovation. Think about Edge AI. We are seeing these engines being stripped down to run on hardware that isn't even computer-like. There are versions of these runtimes being optimized for embedded systems in cars, medical devices, and industrial sensors. vLLM is great for the data center, but llama.cpp is what's going to be running in your smart fridge or your security camera in a year.
I'm still stuck on the multimodal thing though. If I want to build an app that listens to my voice and responds, and I'm using Ollama, am I just waiting for them to catch up? Or is there a deeper technical hurdle there that open source is struggling to jump over?
It's a bit of both. Part of it is the data moat. Training a truly native multimodal model like GPT-4o requires massive amounts of interleaved video, audio, and text data that is hard to come by in the open source world. But the engines themselves are evolving. The hurdle isn't the math. The math of an audio signal isn't fundamentally different from the math of an image once it's converted into tokens. The hurdle is the orchestration. How do you efficiently pipe audio data through a specialized encoder and then into the language model without creating a massive bottleneck? As of 2026, we're seeing adapter technologies like QFormer or specialized projectors that act as the bridge. It's getting there, but it's still the early adopter phase for multimodal local AI.
It feels like we're in the Linux in the 90s phase of AI. You've got these powerful but slightly clunky tools that the pros love, while the general public is using the Windows equivalent, the big web interfaces. But eventually, the Linux of AI, these engines, will be the invisible backbone of everything.
That is a great way to put it. Most people using a website today don't realize they're interacting with a Linux server. In 5 years, most people using a smart app won't realize there's a tiny version of llama.cpp or a vLLM instance running in the background. The fragmentation we see now, all these different engines, is actually a sign of health. It means the community is exploring every possible niche, from the smallest CPU to the largest GPU cluster.
So, if you're a listener sitting at home with a decent laptop and you want to start, where do you actually go? Because the choice is still paralyzing. Do I go for the ease of Ollama, or do I try to be a power user with llama.cpp?
I always tell people to start with Ollama. The friction to fun ratio is unbeatable. If you can download a file and run a command, you have a world-class AI on your machine in 5 minutes. It's the best way to understand what your hardware is capable of. But if you find yourself wanting to build a specific product, say you want to build a tool that summarizes hundreds of documents at once, then you need to graduate. You look at vLLM if you have an NVIDIA IA chip and want speed, or you look at llamafile if you want a simple way to distribute your app to other people.
What about the hardware race? We recently talked about how Mac Minis are becoming these accidental AI powerhouses because of their unified memory. How do these engines specifically take advantage of that? Because that seems like a huge advantage for the open source world.
It's the unified memory advantage. In a traditional PC, you have system RAM and video RAM on your graphics card. If your model is 20 gigabytes and your graphics card only has 8 gigabytes, you're in trouble. But on a Mac with 64 gigabytes of unified memory, llama.cpp can treat that entire 64 gigabytes as a giant pool for the AI. This allows consumer-grade Macs to run massive models, like the 70B or even 100+ B parameter models, that would require 2 or 3 expensive NV1D IDI. A cards on a Windows machine. These engines are specifically tuned to offload layers of the model to the GPU until it's full and then handle the rest on the CPU. It's this beautiful, waste not, want not approach to computing.
It's almost like the open source engines are scrappy. They're making use of whatever is lying around, whereas the proprietary stacks are like, I only eat 5-star meals served on a TPU platter. But let's talk about the cost of inference. We've done episodes before about why it costs more to run AI than to build it. If a company switches from an API to running their own vLLM cluster, what are the hidden costs they aren't seeing?
The hidden cost is humans. When you use an API, you're paying for convenience. When you run your own inference stack, you're now a system administrator. You have to worry about load balancing, cold starts, hardware failure, and keeping your engines updated. vLLM is fast, but it requires tuning. You have to decide how much memory to allocate to the KV cache versus the model weights. If you get it wrong, your performance craters. For a lot of companies, the sticker price of the API is actually cheaper once you factor in the salary of the engineer needed to manage the local cluster.
That's the classic build versus buy dilemma. But for the individual developer or the small startup, these engines are a gift. They're basically giving you the brain for free, provided you can pay the electricity bill and the hardware tax.
And let's not overlook the model engine synergy. Every time a new model comes out, like when Mistral or Meta drops a new weight file, the community is in a race to see which engine can support it first. Usually, llama.cpp wins that race within hours. The proprietary providers are much slower to adopt outside models because they want you in their ecosystem. If you want to experiment with the absolute cutting edge of architecture, like Mixture of Experts or Mamba models, the open source engines are the only place to do it.
I find it fascinating that the big tech guys don't use these, not because the engines are bad, but because they are too general. It's like the difference between a Swiss Army knife and a specialized surgical scalpel. The Swiss Army knife, the open source engine, is amazing because it does everything decently well on any hardware. But if you're doing brain surgery on 1 billion users, you want the scalpel.
That is exactly it. And there is also a legal and strategic layer. If Google used vLLM, they would be dependent on an open source project they don't fully control. They want vertical integration. They want to own the silicon, the compiler, the runtime, and the model. That gives them total predictability. But for the rest of us, the everyone else, Daniel mentioned, predictability is less important than possibility. These engines make things possible that were impossible just 3 years ago.
So, looking forward into the rest of 2026, where do these engines go from here? We've got speed, we've got portability, and we're starting to get multimodality. What is the final frontier for a tool like Ollama or vLLM?
I think the final frontier is agentic autonomy. Right now, these engines are reactive. You give them a prompt, they give you an answer. But we're starting to see engines that have tool use built directly into the runtime. Imagine an engine that doesn't just talk, but can automatically decide to run a Python script, search your local files, or trigger a webhook, all without the developer having to write complex wrapper code. vLLM is already experimenting with speculative decoding, where a tiny, fast model guesses what the big model will say to speed things up. We're moving toward engines that are smarter about how they think, not just faster at typing.
It's like the engine is becoming a manager of the model, not just a reader of the model.
Precisely. And we're seeing this play out in the edge space too. There's a lot of work being done on distributed inference, where your phone and your laptop and your smart fridge all work together to run one giant model. You could have a home AI that is spread across all your devices, powered by a decentralized version of these engines. That sounds like sci-fi, but the foundational math is already being baked into the latest versions of llama.cpp.
That is a wild thought. Your whole house as one big distributed brain. I can see the appeal, but I also see the potential for a smart home to get a lot more opinionated about how I'm loading the dishwasher.
Corn, I noticed you didn't rinse that plate. According to my local Mistral instance, that's a 3% decrease in hygiene efficiency.
Exactly why I want my AI to be local, so I can turn it off when it gets too cheeky. But seriously, the practical takeaways here for anyone listening are pretty clear. If you're a developer, you need to know this landscape. You can't just rely on OpenAI's uptime. You need to have a plan B that involves one of these engines.
My actionable insight number 1. If you haven't yet, download Ollama today. Run Llama 3 or Mistral on your machine. See how it feels. It will change your perspective on what intelligence is when it's running on a piece of metal you own. And insight number 2, if you are building for others, look at vLLM. The page detection breakthrough is real, and it is the difference between a toy app and a tool people can actually use.
And for the average Joe listener who isn't a coder, just know that the AI wars aren't just about who has the best chatbot website. It's a battle for the infrastructure of thought. These open source engines are making sure that the future of AI isn't just a few giant brain towers in the desert, but something that lives in our pockets and our homes, under our control.
It's the democratization of inference. It's a mouthful, but it's the most important thing happening in tech right now. We are moving from AI as a service to AI as a right.
On that high note, I think we have sufficiently unpacked Daniel's prompt. It is a complex world, but a fascinating one. Before we wrap up, a big thanks to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes. And a huge shout out to Modal for providing the GPU credits that power the generation of this show. Without that serverless muscle, we wouldn't be able to dive this deep every week.
This has been My Weird Prompts. If you are finding these deep dives helpful, do us a favor and leave a review on whatever podcast app you're using. It genuinely helps new people find the show and join the conversation.
We will be back next time with whatever weird idea Daniel throws our way. Until then, keep your models local and your prompts curious.
See ya.
Guy, this episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to